Hello everyone, welcome to my channel. My name is Chandra Chatterjee. I am an M.Tech student at IIT Madras. So I have been doing some videos on ML topics on my playlist in the YouTube channel. So this will be the fourth video, and as you have already seen the title and the thumbnail, it is going to be a very interesting video because we have a special guest, or you can say a special person or a special character that will be trying to teach uh, whatever this video contains, right? So as you can see already, I have a collab notebook open with the name, as you can see, grid searching CV. Why I have named it grid searching CV is it will become very clear in the next few minutes, because this video is about, as I had already mentioned in some of the previous videos, this is about hyperparameter tuning. Now in the first video of the playlist, we tried to understand how to simply use the SVM model on the iris dataset, right? So in this video, we'll also use a new dataset and we'll use it from some platform known as Kaggle, and try to understand, also see how to import data directly from Kaggle into the Collab notebook so that we can use it easily, right? Without having to download it into our local machine or import it into Drive, then access into Collab. We can directly access Kaggle dataset present in the Kaggle repository using this corresponding collab directly using some commands, right, in collab. And we will see how hyperparameter tuning is actually done on SVM for that particular data set. As we had started with SVM, so let us keep it simple and go forward with SVM. Now in this video, just to make it clear, I will not be teaching anything about the hyperparameters. We will not try to understand what are hyperparameters or what they actually do for the SVM, but we'll just simply consider them as variables, and we'll have to keep in mind that by changing the value of these variables, we have the SVM giving us different performance for the same dataset, right? So we have to always keep in mind that these will just be some kind of variables that the model actually depends on, and changing these changes the performance of the model on the given dataset, right? And there is an important difference between hyperparameters and parameters. So when we are talking about model training and everything, there are two kinds of variables that a model depends: hyperparameters and parameters. Parameters are those such as weights and biases which the model learns you from the dataset itself while training, right? Whereas hyperparameters are those variables of the model, or you can call it attributes of the model, that are fixed by the user to get a particular result from the model, right? So this is what is the hyperparameters, and we'll see how to tune some of such hyperparameters for SVM, support vector machine model, for the corresponding dataset, right? So let us continue. But before that, as I have already mentioned, this video is going to be very interesting. So let us introduce our guest. So let me just open up the application. You might find it funny that I am bringing a guest by opening up an application. There is an application known as VUP in Steam, right? Every Most of the computer science students, or students who like to play a little bit of games and everything, use good softwares, know about Steam. There are many with various important software for ML engineers present in Steam, and one of the animation related software that is present in Steam known as VUP. So I'll be using that application, and you will see what it happens when I open that application, right? So let's see. So as you can see, there is an animated character just below my image, and you can see as I move my head, the animated character actually copies my head movement exactly. And if you can also see, if I blink my eyes, the animated character blinks his eyes, tries to make the mouth movement same as that of mine, right? So this is a very important achievement in the field of animation. Now, this is a product of extensive or very intensive ML techniques, especially deep learning and computer vision, right? So let me turn off myself first. Just you guys will be able to hear my voice only, but let me just turn off my video and see how it goes using this animated character to teach hyperparameter tuning on SVM, right? So let's continue. So as you can see, I have replaced myself with the animated character, and now let's see how this video goes on, right? So let us continue. So first and foremost, let us try to understand how to import the data from Kaggle, right? So I have already bookmarked the website. You can look at the website where the data is available. So this is the data, right? So this is the heart attack analysis data, right? There are several features, as you can see. Every description of the data is present over here. There are total 14 columns, 13 of which are actually features, I think, including age, as you can see, gender of the person, chest pain and type, and finally there is a actually class or the target. As you can see, the target is 0, that means it represents less chance of a heart attack, and 1 means more chance of a heart attack, right? So we do not have to download this data into a local machine or anything. I will just show how to simply we can import it into collab, right? So first of all, what you need to do is you need to click at your accounts or profile section, go to the accounts, and in the account section there will be an API column, right? So in the API part, API row, there will be an option of create a new API token. So we'll simply create a new API token and it will give you a JSON file to download. You can download it wherever you want. So I have downloaded it, right? So now we'll go to the collab. As you can see in the collab, what we will do, we'll click the file option. So let it allocate some runtime. Okay, now the file option has been clicked, and now we'll click this particular file option with the arrow upwards, including that you suggesting that we actually want to upload a file into this collab file. But always we have to remember that it will get deleted after the runtime is over, right? So it will show us a notification message of such. So I will click on the kaggle.json. Now see, the notification says the uploaded files will get deleted when this runtime is recycled, right? So let us do that. Now to use this JSON file to download the data, what we need to do is we need to first install Kaggle. Most of the collab files today have already Kaggle installed, so it says already requirement already satisfied. Now what we will do is we'll make a directory mkdir dot Kaggle, right? Then we'll copy kaggle.json to the Kaggle directory, right? Yeah. So now it is copied. So now what we will do is we will give some actually what are known as file permissions. This is nothing but giving some file permissions so that we can actually use it to download. So after giving the file permissions, what we will do is we will download the dataset, right? So we will have dataset download and we will keep the name of the dataset. Now if I execute it, it is showing that it is not present. Let me see that. Yeah, so it says it has been downloaded 100%, right? So as you can see, if you go there and refresh it, there will be a particular file. Now this is actually a zip file. You cannot use simply the zip file, so you have to unzip the file, unzip, and we will simply copy the path and send it to over here. So it has unzipped. So as you can see, now there are two CSV files, hard.csv and o2 saturation.csv. So we will be actually working on the hard.csv. We do not need the o2 saturation. It is for some other project provided in the same repository as well, right? So now it is time for some imports. We will be using SVM. So let us import that. We will also need the model selection library of the sklearn to import the train test split, right? Let us use this input, and if you need it in further down the code, we will simply import whenever we need them, right? So these are the imports. So now let us try to load the data set. So we will call it data equal to cd.read csv, that is a csv file, and I simply will copy path and will paste it. Now if we print the data, so as you can see, this is the corresponding data. It has several features: age, sex, cholesterol, FBS, and these are all features determining the chances of an heart attack. Right, 1 represents high chance of an heart attack, whereas 0 represents low chance of an heart attack. So as this is the data, let us split it into correspondingly x and y. Right. So we will simply use the ilog function. So after splitting the data, now let us, after taking the data into x and y in the features and the corresponding labels, now let us try to split the data into training and testing. Right. These are all, these are everything that we have all previously done. So if you want, you can simply skip, but I am doing it again if someone was not clear about all the processes or the syntaxes, right? So we'll use the train test split function, and we'll simply pass the x and y. The test size will be set by us. So let us set it to 30%. We'll use stratify, of course, because it is a classification task, and it will make it will try to avoid as much class imbalancing as possible, right? And we'll have a random set equal to, let us have 48. So there is some error. Let us see. I have spelling wrong. So now let us see the steps, right? As you can see, there are 13 features and 212 uh, entries, right? Total there were 303 entries. So let us see the test step, and we'll understand that it has been split into 70-30. As you can see, it is split into 70-30 ratio, right? So we can remove this output so that it does not look bad. So after we have split it into test and train, it is very simple. We'll just call an object of the SVC uh, class and create a model, right? So we'll make model equal to SVC, and simply you will do model dot fit x train y train, right? So this is the simple model without any uh, hyperparameters being initialized. So this model is actually using default values of the hyperparameters. So before understanding what the hyperparameters are for the SVM, we'll go to the sklearn.svm library website and try to check them out. So first of all, before that, we are just trying to look how much default hyperparameter oriented SVM will give accuracy on this particular orientation of the data and the dataset, right? So we'll have ypred will predict over the x test data, and now we can see what is the accuracy. The spelling was mistake, so let me run it again. So as you can see, ypred is equal to model.predict x test. Now let us print the accuracy score. Again, I think accuracy score spelling is wrong. Let me see what I took. I had taken capital Y. We have to keep in mind of these capital and small letters. The convention is keeping the x or the feature vector capital and the label in small letters. So I am trying to follow that, but You can do whatever you like. So as you can see, it is giving approximately 70.3 70%, 70.32%, or you can say 33% because it is 3 to 9, right? So it is giving close to 70%, which is not good and not bad as well. So now we'll try to understand how you can tune this model and make the accuracy much better. So we will try to understand how you can tune the model for specific metrics, right? That is also very important, right? Because in some instances or in some tasks, accuracy is very important, whereas in some tasks such as medical diagnosis and disease classification tasks, the recall is very important. Similarly, in some cases, precision is very important. Now, what is precision? What is recall? You might have to go through the theory a bit to understand what is precision, what is recall. So these are based on true positive, true negative, false positive, and false negative values that are produced by a model. So recall is kind of, for example, a simple example would be if you are trying to classify a cancerous and a non-cancerous patient, and so recall will give the idea, or you will try to record the instances where a cancerous patient has been classified as non-cancerous. So as you can see in the task of classifying a cancer, recall is very important because it is of more risk. Classifying a non-cancerous patient as non-cancerous has more risk than classifying a non-cancerous patient as cancerous, because if you classify someone who is not cancerous as cancerous, in further stages it can be easily diagnosed and understood that it is false. But classifying someone who is who is cancerous as non-cancerous is very harmful or has a very high risk, because the further diagnosis might not be made on such a person, right? So recall, which records such a corresponding value, is very important in those tasks. So so using ML models for those tasks are specifically hyper parameter tuned to get better recall with also moderate accuracy. We do not want to just tune to get better recall by losing the accuracy completely. That is also not actually expected, right? So now let us go to the sklearn.svm library and see what are the hyperparameters, right? So this library is present in Sci-kit learn, sklearn. So you can simply go to this website, and now if you see, there are some parameters: the parameter c, the parameter kernel, then there is the degree, which is degree of the polynomial kernel function. So this is a parameter that is only hyperparameter, that is only actually used when we are using the polynomial kernel, and then there is the gamma value, right? So we will try to hyperparameter tune the c, the kernel, and the corresponding gamma value, or we can also try just hyperparameter tuning the c and the gamma value, keeping the kernel as fixed RBF kernel, right? RBF is one of the most robust kernels used for majority of tasks where SVM is actually used, right? So we'll keep the kernel as RVM, and we'll try to hyperparameter the values of C and the gamma, right? So now let us try to define or understand how grid search actually works, right? So as the name suggests, it is a combinatorial searching technique, right? So what it does is it takes different values of the parameters. So let us define the first of all parameters, right? Param grid, it will be a dictionary, so you can easily understand it, right? So we'll define the c as having values from 0.1, 1 comma, you can have it 10 comma 100 comma 1000, right? Similarly, and as I've already mentioned, we'll fix the kernel to be RBF kernel, and now we'll define the different gamma values that we want to try with, right? So we'll start with, let us start with 10, 1, 0. Let me have it 0 0.1, 0 0.01, 0, then we can have 0 0.001, 0 0.001, or one more zero you can have it. So these are the corresponding gamma values that we have, right? So the param grid is now defined. So now what we will do, we will import the grid searching class, right? Which we forgot from. So it is also present in model selection only. So we'll import this, import the grid searching CV and then run it. And now we'll create a object of the grid searching CV and name it grid. And now what we'll do is we'll pass the model, that is SVC, comma the following grid or the parameter grid values, right? And we'll have refit equal to true, and let us have verbose equal to 3. I don't think we need anything more. We will have this, and then we'll have grid dot fit x10 and y10. So as you can see, it is executing for every value, right? So after doing, after this is the training, now as you can see, the training is completed, right? So what the grid searching does is, so but default value of the CV, now grid searching name includes grid searching CV. So it stands for grid searching with cross validation. So as you can see, the default number of cross validations or default number of folds for cross validation is actually 5. So as you can see, it is doing 5-fold cross validation as we call it. Now we have defined the parameter grid, right? This is the hyperparameter values that we want to use uh, for different combinations, right? So C has actually, let us see, 5 values, and similarly gamma has 3 and 3 6 values. So and the kernel is RBF, so it will try every particular combination of C kernel gamma, right, for training and see which one generates the highest score, right, and then use the one that generates actually the highest score. Now we'll see. So we simply do not mention what we actually want to perform the hyperparameter tuning for specifically, right? So we have another option of mentioning scoring. So if we mention scoring as accuracy and then again run it. So now what we will do is it will try to obtain the hyperparameters that is best suited for obtaining the highest accuracy for this particular task, right? So now after we have trained this, as you can see in the training, for every step you can see, for example here you can see it is training for C is equal to 1, gamma also equal to value of 1, and the kernel RBF, and the score that is actually accuracy it is obtaining is 54.8. Similarly, there are instances where it is obtaining much higher accuracy. For example, it is obtaining 73.8, and also so it will try to record the values of the hyperparameters for which it is obtaining the highest scoring value, as we have mentioned the scoring value in this grid search object of the class, right? Grid search CV. So now what we will do, we will try to predict using this grid. Let us name it as simple pred equal to grid dot predict, and we'll pass the test data, and then we will see what is the accuracy that this particular model generates, right? So as you can see, it is generating 83.51% accuracy. So which is much better than the default SVM running on the simple model, right? So which was above. Let us see where it was. Yes. So the default SVM with default hyperparameters was generating 70.3. And if we go to the SVM library, you can see what are the default values. The default values of the C were 1, and the default value of the kernel was RBF, so we kept it same as RBF, and the default value of the gamma was actually scale, right? So it ranges, it uses corresponding value using the corresponding formula, as you can see. Whereas we specified the corresponding values of C kernel gamma within a particular range, and found out that after tuning it using perfect C, gamma, and kernels, we can obtain a much higher accuracy than the default values, which is thus we are obtaining 83.5% accuracy, which is much higher compared to 70%. Now, if you want to see what are the parameters, hyperparameters that led to this highest scoring accuracy, what you can do is you can simply go grid dot, as the model named is grid dot best estimator. I think I have spelled it wrong again. Let me go there. So as you can see, the value where it is generating the best accuracy is the value of C of 100, and gamma is equal to 1 upon 1000, right? Yes. it is 0.00030 zeros and a corresponding one. So this is the corresponding value, best hyperparameters for which it is generating the highest accuracy of 83.5% on this particular data set. Further tuning can also be performed to improve the accuracy much further. So it will require understanding the other hyperparameters that are present in the SVM and the other kernels. So we just assumed for our simplicity that these are just simple variables whose values on being changed changes the performance of the model, right? As you can see, for different values giving different scores, right? So these are known as hyperparameters and they can be easily tuned with keeping in mind what kind of score that we are trying to base our model on, right? So if we change the scoring from accuracy to recall, it will try to get the best hyperparameters that generate the highest recall, right? So this is how grid searching CV is actually done. There is another function that is generally used for hyperparameter tuning known as random searching. So random searching actually depends on number of iterations that you are allowing the model to run, and it will randomly take particular set of values of the hyperparameters and feed them in the model and try to obtain the highest accuracy among those within that particular number of iterations. Whereas grid searching is much better because it is a combinatorial approach. It tries every combination that is actually possible, but it is computationally little bit expensive, right? So this was all about grid searching. So I hope you liked it. Also, the animated character teaching you should have been interesting. So let me just come to end the video. So thank you everyone. Please follow and like the video. Do subscribe to my channel for more interesting and upcoming videos and ML tutorials. So I am aiming to actually make these concepts very hands-on and very simple for people who do not have a better or deeper understanding in programming and else, right? So I am hoping I am doing a good job, and you can let me know in the comment section as well. And all these websites, all these videos will be present in my website as well. You can check it out, and I will try to upload the code in GitHub and share it in the YouTube description as well, right? So do check out in the description. The code in the will be present in the GitHub, and uh, you can always download it from GitHub and try your own experimentations on this code, and I hope you do. So thank you everyone, thank you, and please like and subscribe.